Hello. Hi friends. My name is Nilesh. In this video, we are going to continue the 15 factor apps series that we started in the earlier one. This is the second part of the series, and let's start by looking at what are the different things that we covered in the earlier video, which was part 1, and what we are going to do in this particular video. So in the earlier video, we started with looking at what are the 12 factor apps which is used for deploying cloud native applications or developing and deploying cloud native applications. And then we also looked at the additional 3 factors, which is the API first, telemetry and authentication, which has got added over a period of time. And now we have a set of 15 factors which define how a cloud native application should be developed and deployed to different cloud environments. So in part 1, we covered 2 of these factors. First one, which is the code base, and second one, dependencies. In this second part of this series, we are going to talk about the next 2 factors, which is the config or configuration and backing services. So configuration in the earlier series or the earlier 12 factor apps referred to storing configuration in the environment variables, storing everything as a config in environment variables. And the backing services was to treat the backing services as the attached resource. So let's do a deep dive into these 2 sections or these 2 factors in this video. Let's start with looking at config or configuration. What does configuration really refers to? Basically, configuration is anything that varies across the environments or across the deployment. It can be your developer workstation where the code is developed and tested. It could be the other environments where the actual testing happens, like a QA environment or a staging environment, and then obviously when the code is deployed to target production environment. So what are the different kinds of values or configurations that can change or vary? This could include various things like the URLs and information related to things like databases, web services. It can be SMTP servers. It can include configuration, which is typically stored in your properties files. If let's say we are coming from Java background, then properties file is one of the common way in which the configuration settings are stored. In some other programming languages like .NET, XML is common, like web.config or machine.config file. And of late, for all the configuration related things or infrastructure as code, YAML configurations are quite popular nowadays as well. So how do we get around with configurations? If we look at the earlier versions, people used to store configurations in let's say the source code. We had hard-coded configuration settings stored in the configuration files in the source code, but this becomes a problem when we start deploying applications. We need to externalize the configurations so that our code and the config is separated, and we can deploy the same binary or same version of the code to different environments. One way to externalize is, as we said, using a properties file or external configurations file. But storing this configuration externally doesn't solve the problem as such. If we have a code which is externalized, if we have database settings which are externalized, they could still pose a risk to the application if, let's say, this is exposed to people, or if this gets hacked by people who are not part of the organization. A typical example is like the API keys which are used to connect to the cloud providers. It could be AWS, GCP or Azure. We find sometimes that the credentials are stored in Bitbucket or GitHub, and this causes a lot of sensitive information being exposed over the internet, and it does expose a risk to the application and the organization's capability to handle information. So from the way in which we can externalize configuration and protect it from being exposed to unknown parties or getting into the hands of people who should not get it. One way is to protect this using a service or a product which can be used to expose the configuration externally. On the right hand side here, or on the screenshot, if we see here, I've given 2 examples of how the configuration information can be stored. On the left hand side, this is a JSON file which is used by a web API project in .NET, and we can see that the URL to one of the service API URL is hard-coded here. Now, if we have to deploy this to a different environment, we might definitely want to change this as per the needs of the target deployment environment. The other way is here on the right hand side, we see a Spring properties file, Java Spring Boot application, which has a properties file. And here we have used the environment variables to store the database URL, username and password. So this kind of information is typically stored in the source code management tools. A good practice is to externalize this and to have a process which is, let's say, continuous integration, continuous deployment, which replaces these credentials at the time of deployment in the target deployment environment. And nowadays, all the cloud providers, they come up with one way or the other to externalize the configuration. Microsoft Azure, for example, has Azure Key Vault. AWS has AWS Key Management Solution, KMS. And similarly, there are other products which help us, like HashiCorp Vault, which can be used to store the configuration externally and provide rules and the restrictions using which only the people who are supposed to access that particular configuration can access it. And there are also APIs which the application can use to access this information without manual intervention. So a litmus test to understand if the configuration is externalized and if the application is following a best practice is, imagine that tomorrow your application source code has to be made public. It has to be made open source. If you make it public on, let's say, a platform like GitHub, would you be providing or would you be sharing any sensitive information? That gives you an idea if your application's configuration is handled correctly or not. If you are able to post your code, or if you are able to publish your source code without exposing any sensitive information, that means you are good and you have externalized your configuration and you are managing the configuration well. So as I said, some of the enterprise products could be things like HashiCorp Vault. There is also CyberArk, which is used quite commonly in enterprise solutions or situations to handle the configuration information. And then cloud providers, they have their own ways and means of providing external source of configuration. A good practice or recommendation when you choose an external provider for storing configuration is to make sure that it allows versioning. So if you have to revert back to the earlier version, you can go back in time and you can apply an earlier configuration. And this also allows us to have an audit of who managed or who changed the application configuration when it was changed. Those kind of audit capabilities are also available when we have version management integrated into the third-party product. Let's move on to the next attribute, which is the backing service. What is basically a backing service? Backing service is anything that application depends on to make its functionalities work. So some of the common examples of backing services include file storage, databases, messaging systems. It could be things like Kafka or RabbitMQ. It could be caching systems like Redis or Aerospike or any other caching system that you might be using. It could be SMTP servers for sending emails. And these are just some of the examples. Anything that allows the application to extend its functionality using external service can be treated as a backing service. Now, when we use backing service, in the diagram here, I've shown a couple of examples. One which is related to the storage service. So in a cloud native application, we don't store data to the local disk. It is anti-pattern to store anything and assume that a local disk is available. So usually in cloud native applications, we find that object storage or external storage is used, like Azure Data Lake storage for applications which are deployed on Azure, or it could be S3 as an example for Amazon AWS. And likewise, the other cloud providers, they have their own abstraction over the storage. Next example could be authentication service, and same way database services and messaging services. So the application might use one or more of these services, and these are the backing services which are required for the application to function correctly. There is another concept which is linked to the backing services, which is called as the bound resource. A bound resource is basically something which binds the application to the backing service. If we take database as an example, it is the URL or the identifier where the database is hosted along with the username and password. If it's a messaging service, again, it can be the username password which is used to connect to messaging service. In case of the file storage, it would be the location of the file storage, the S3 bucket or ADLS, the blob store, along with the keys which are used to connect, or the credentials which are used to connect to that particular storage. So when it comes to backing services, the concept of backing service is the application declares what are its backing services, and it declares a need to have a backing service so that in a cloud environment, the cloud provider or the way in which these backing services are connected to the cloud, it can be bound to the application. So the application declares a need and allows the cloud environment to provide the resource or perform the resource binding for that particular backing service. External configuration again plays a key role in this, because if we don't externalize the configuration, we won't be able to change the configuration at runtime to change the backing service need. So a typical example when we use databases is to have like a local database while the developer is testing and building the application, to have an embedded database, and then when it gets deployed to, let's say, a QA environment or staging environment, to use a different database. So in this case, having external configuration is a key, which allows us to use a different configuration locally and a different service or a different configuration in the target environment. And the third thing, or basic rule of resource binding, is that it should also be possible to attach and detach the backing service from the application without redeploying the application. Example here is, let's say you have deployed your application in different regions in your cloud provider, Microsoft Azure for example, and you have a East region and a West region, and there is a outage in East region. Now you need to switch, let's say, your database connection or the database which was hosted in the East region to a DR site, which could be your West region. In this case, if your configuration is hard coded, you need to redeploy the application. But if you have externalized the configuration, the administrator can bring up the database or make the secondary as the primary, and all it takes is the switch in the configuration to say point to the West region. And with that, without redeploying the application, we can restore the services quickly as possible. So I hope that these two things that we talked about the backing service and also the configuration, the two parameters which are part of the 15-factor applications, helps you to understand a bit more about cloud native applications and how we can build and deploy applications which are scalable and which are resilient across cloud providers. So hopefully you found this video useful. In case you like this, please hit the like button and subscribe to the channel. Thank you for watching this video.